Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 54 spiral matrix. We're told that we're given an n by n matrix and we need to return all the elements of the matrix in spiral order. So here is an example: 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the matrix, but we return 1, 2, 3, 6, 9, 8, 7, 4, 5. So we return it in a clockwise spiral order. So again, we're given our matrix as an input and we return the spiral order as the output. And we're given some constraints. So how can we solve this problem? Well, it's medium difficulty. We know we're dealing with a matrix, and the solution that I'm going to, the way we can solve this problem basically is going to be using a 4-pointer solution. So having a top pointer, a bottom pointer, a left pointer, and a right pointer. And when the pointers converge or meet each other, that's when we know our spiral has finished. So basically, each level of the spiral will cross off the row and a column for each iteration of each spiral. And I think it'll make more sense as we get coding. So let's hop into the code. Today we're going to be coding this solution in TypeScript. So let's set our result order, or our result list, which is going to have the result of the spiral. So we'll set that initially equal to a array of numbers and just an empty array. And let's actually create our pointers and our 4 pointers. So the one left and right equal to 0, and right pointing equal to matrix 0.length, and our top and bottom is going to be equal to top and bottom equal to 0 and matrix dot length. Okay, so now that we've got our pointers, let's actually get our while loop and keep on doing a spiral. So we're going to say while, so our base condition is going to be while the pointers don't converge. So while left is less than right and top is less than bottom. Well, we know our pointers haven't converged, so we can carry on doing our spiral. And now what we want to do is we know that if we're at the top and we're just beginning our spiral, the first thing we want to do is put all the elements in the top of our matrix into our result. So we just have to say for let I equals left, I is less than right, I plus plus. Okay, and we can just push the numbers. So we can say push matrix top I. And of course, we want to, now that we've finished our putting all the elements in the top row, we can now increment our top pointer so that we don't actually go to that top pointer in the next spiral. So we're basically marking this top row off. And now I'm just going to copy and paste this for all 4 of the directions. So for bottom, for the rightmost column, for bottom, and from the bottom to the top. So what we want to do next is now that we've done our top row, we want to do the bottom right handmost column. So we start from the top and we say while we are less than the bottom, so while we haven't reached the bottom, then we're going to push right -1. and then we can increment, or actually we can decrement our right pointer by 1. And the next is going to be our bottom row. So for the bottom row, again, we're going to start this time from right minus 1. And we're going to say, while we're less than, or actually while we're greater than or equal to the left, let's decrement our I variable. And in our matrix, we want to push bottom I, or actually bottom minus 1 I. Remember, we're doing zero-based indexing. And now we can decrement our bottom pointer. And now for the left-handmost, or for the leftmost column, we need to now put all those elements up to the top. So we're going to say I is going to be equal to bottom minus 1. And as long as I is greater than or equal to top, we can say I minus minus. And now we want to push matrix of I and left. Okay, and now we can increment our left pointer. And once we've finished our while loop, well, we know that the pointers have converged, so our spiral is finished, and we can just return our result. So return result. Let's run our code. Oh, it's a syntax error. Oh, we can probably do it like this: left equal 0, and then right equal matrix.length. That's probably going to be the syntax that we want to do. I keep going back to thinking like Python. Top equals 0, and bottom equals matrix.length. Let's run the code again. And we missed a comma. And I think I may know what this problem is. I think this problem is to do with needing to add a guard check. And this, I believe, is to do with like single column matrices, or like a one row matrix. So we can basically just copy our condition over here and say if it isn't true. If we don't satisfy the condition, we want to just break out of our while loop. Let's run the code again. Oh, fantastic. And we passed 2 sample test cases. Let's submit our code now, check our solution is valid, and it is. We're accepted. So in terms of time complexity, we're looking at O of m times n time complexity, where m and n are the rows and columns, and apart from auxiliary variables, we aren't using any extra space, so it's going to be a constant space, so big O of 1 space complexity. So time is going to be O of m times n, and space is big O of 1. So I hope you guys enjoyed this video, and I'll catch you in the next one.